Hello friends, welcome to this session of cost functions. In this session, we are going to focus on the cost functions, its concepts, and a small numerical problem, and finally ended with a small summary about the use of this particular cost functions. To start with, let me first focus on the content of this today's presentation. In this presentation, we shall be focusing on firstly the definition of cost function. Then we shall try to see what are the examples of a short-run cost function, how do we formulate it. Then we shall try to see thirdly the long-run cost function, its example. Its example we shall try to see, and finally summarize our total presentation. So let me start off with firstly the definition of a cost function. Yeah, a cost function is nothing but it is a symbolic or a mathematical representation of the relationship between the total cost and output of a firm, and it is known as a cost function. In any organization, we have a data relating to the total cost, and we have also a data relating to the variation in output. Now we know that as and when output goes on changing, the total cost also goes on changing. This relationship between the total cost and the output is mathematically or symbolically represented with the help of a cost function. Now, there are two types of cost functions, two ways in which we can represent the cost function, namely a long run cost function or a short run cost function. Firstly, let us try to see how do we represent a long run total cost function. The long run cost function is having a constant term, is dependent upon a constant term and the output. So an example of this total cost function or a long run total cost function can be simply given as 10 plus 4q plus 5q square. Here in this function, you see that there is a constant term plus there is a component 4q minus 5q square, which varies with the changes in output. Now, when this kind of a function is given, where there is a constant term mentioned and there is a component which changes with the output, is known as a long run total cost function. At the same time, we can represent the relationship between the total cost and output without the presence of a constant term. When the constant term is not present, then we call it as a short-run cost function. The example of a short-run cost function is TC is equal to 4Q minus 5Q square. So here in this, you see that both the elements 4Q and 5Q square vary as and when the output is going on changing. And here the function does not contain a constant term. So this is a representation of a short-run cost function. So the meaning of this particular slide is that in every organization the total cost figures are there, and there is a data relating to the output. The relationship between the variation in the output and the variation in total cost can be studied with the help of cost functions. Now these cost function can be represented in the form of long run cost function and short run cost functions. The long run cost function has a constant term and the short run cost function does not have a constant term. This is the very simple difference between the long run and the short run cost functions. Now let us try to see what are the various cost concepts which can be derived from a cost function. Given a cost equation, of this particular type, like TC is equal to 10Q plus 4Q minus 5Q square, what are the various concepts which can be derived for further analysis? The total number of cost concepts which can be derived are 7 in number. 1, 2, 3, 4, so on up to 7 in number. What are those cost concepts which can be derived from the cost function? Are total fixed cost function, total fixed cost, total variable cost called as TVC, the total cost, which is nothing but the summation of total fixed cost and total variable cost. Then fourthly, average fixed cost denoted as AFC, the average variable cost, which is denoted as AVC, the average cost, the AC, which is nothing but the summation of average fixed cost and average variable cost, and lastly, the marginal cost. In the further slides, we shall try to see how these individual concepts are calculated from a given cost function, how these individual 7 cost concepts are calculated from the given cost function, and what is the nature of their graph. All these things for all the 7 cost concepts we shall try to see. So let us start first with the total fixed cost function or total fixed cost equation. So let me go to the next slide. The first one is the total fixed cost. Now, what is the definition of a total fixed cost? The total fixed cost is nothing but that component of the total cost or that component of the total cost equation which does not vary with the variation in output. As in when you are increasing the output, that component of the total cost which remains the same is known as the total fixed cost. The problem we can actually, you can say, illustrate it very clearly with the help of a numerical problem. For example, if the total cost function of a firm is given as TC is equal to 2 plus 3Q plus 4Q square, we can determine the total fixed cost equation or function. We can also determine total fixed cost at 10 units of output and draw the graph of this total fixed cost also. So we can say, how do we work out this solution? Yeah, from the total cost equation, that portion of the equation which does not change with the variation output is called as the total fixed cost. And here we see that only 2 is an element which does not change with the variation in output. So therefore, TFC is equal to 2. Then let us go to the second numeric problem, that is TFC at Q is equal to 10. Means when 10 units of output is produced, what is the total fixed cost? The total fixed cost at 10 units of output will again be equal to 2 because this does not change with the variation in output. So such kind of a graph of total fixed cost is given as shown in this particular diagram, where we take output Q on the x-axis and cost on the y-axis. So the total fixed cost does not change with the variation in output. Any level of output you produce, the total fixed cost remains the same. So therefore, it is called as a fixed cost component. Similarly, we can derive what is known as the total variable cost. Second concept is the total variable cost. Now, what does this total variable cost means? That component of the total cost equation or that component of the total cost which actually directly changes with the variation in output. As and when output is changed, that component also goes on changing. Now, this can be illustrated with the problem number 2, where the total cost function is given as TC is equal to 2 plus 3Q plus 4Q square. Now, here we can determine the same thing, TVC equation, TVC at Q is equal to 10, and try to draw the graph of the same. So when we want to find the total variable cost equation, means that portion of the cost equation which changes with the variation in output. Now, in this total cost equation, which is given, you see that 3Q plus 4Q square is the only component which changes with the changes in output. And that is the reason TVC is given as 3Q plus 4Q square. Now, second bit is that find TVC at Q is equal to 10. If you want to find TVC at Q is equal to 10, is nothing but directly substitute 10 wherever Q is there. You just substitute wherever Q is there. So 3 into 10 plus 4 into 10 square. So you get 430. Similarly, we can draw the graph of the total variable cost. The total variable cost will vary proportionately with the output, and the nature of graph will be like this and shown in this particular diagram. As and when output is going on changing, the total cost also goes on proportionately changing. So this is how the total variable cost is actually explained. Now let us try to see what exactly is the total cost. Now the mathematical representation of the total cost, which varies directly with the variation in output. Now, this is nothing but a summation of total fixed cost and the total variable cost. Now, this can be understood with the help of, again, the simple numerical problem where the total cost function is given as total cost is equal to 2 plus 3Q plus 4Q square. And we have to find a total cost equation, total cost at Q is equal to 10, and draw the relevant graph. The total cost equation is already given. That is, the total cost function itself is 2 plus 3Q plus 4Q square. And secondly, if we want to find the total cost as Q is equal to 10, it means wherever Q is there, just substitute 10. Wherever q is there, you just substitute 10 and simplify, you get 432. And the total cost, as I said, is a summation of total fixed cost and the total variable cost. And the variable cost, if these two diagrams are total fixed cost and total variable cost diagrams are drawn on the same graph, then you get the total cost graph similar to the total variable cost. You see, now since the total cost includes total fixed cost, it starts above the origin. It starts above the origin, and the nature will be similar to the total variable cost. So the nature of total cost will be similar to the nature of total variable cost. So this is the third concept which we have tried to derive and explain. The fourth concept is cost concept happens to be the average fixed cost. The formula for average fixed cost is given as total fixed cost divided by output. Now in this formula, the numerator, that is total fixed cost, is constant. With the increase in Q, average cost will always decrease because numerator is constant, only denominator goes on decreasing, means the fraction becomes smaller and smaller. So in simple words, average fixed cost always decreases. So how we can understand this? By taking a small numerical problem wherein the cost function is given as TC is equal to 2 plus 3Q plus 4Q square. 4Q square, and we are supposed to determine AFC equation, AFC at Q is equal to 10, and draw the graph as in the earlier cases. If I would like to have average fixed cost, it is nothing but a ratio of total fixed cost by output. So this is 2 by Q. And to find the average fixed cost at Q is equal to 10, directly substitute Q is equal to 10 wherever Q is there. So I get it as 0.2. And if I want to draw the graph of average fixed cost, you see the numerator is constant, only denominator goes on increasing. So the fraction becomes smaller and smaller and smaller. So the graph is always falling down. Graph is always declining like this. So this is the nature and formula of the average fixed cost. So let us move to the next concept, that is the average variable cost. The average variable cost formula is given as total variable cost divided by the output. Total variable cost divided by the output. And the numerical illustration will help us to clarify the concept of average variable cost. And let us assume that the total cost function of a firm is given as TC is equal to 2 plus 3Q plus 4Q square. Then we have to find average variable cost equation, average variable cost as Q is equal to 10, and determine the graph of ABC. So here the average variable cost, we directly use the formula here, TVC divided by Q. Now what is total variable cost? That component which changes with the output, and that is given as 3Q plus 4Q square divided by Q. So when I simplify it, I get 3 plus 4Q. So this is the equation or the function for average variable cost. Simply average variable cost at Q is equal to 10 is obtained by directly substituting Q is equal to 10 in this average variable cost equation of 43. And the nature of graph, if I want to draw, you'll be observing that it will be a U-shaped curve. It will be a U-shaped curve as given in this particular graph. So average variable cost initially decreases, reaches a minimum, and then goes on decreasing. So this is how the average variable cost changes or varies. Lastly, we can try to pick up the concept of average cost. Now this average cost is nothing but the formula is given as total cost divided by output. Moreover, average cost is nothing but a summation of average fixed cost plus average variable cost. So we can use this formula of total cost to derive the average cost. So this can be understood by taking a numerical illustration. Number 6. The total cost function of a firm is given as TC plus 2Q plus 4Q square. We have to derive the average cost equation. Average cost is Q is equal to 10, and try to draw the graph of the same. Average cost, we directly use the formula total cost divided by output. So this is 2 plus 3Q plus 4Q square divided by Q. When I simplify it, it is 2 by Q, 3 by Q by 3 by Q divided by Q gives me 3, 4Q square divided by Q gives me 4Q. So 2 by Q plus 3 plus 4Q is the average cost equation. Now, when I want to find the average cost at Q is equal to 10, it simply means that wherever Q is there, I substitute 10. So 2 by 10 plus 3 plus 4 into 10. When I simplify, I get it as 43.2. 43.2, and the nature of average cost again will be a U-shaped curve. So average variable cost curve and average cost curve will be more or less of the similar type. So this is how we discuss about the average cost. The last cost concept which we can derive from the total cost function happens to be the marginal cost function. This marginal cost formula is given as nothing but the differentiation of, so this is nothing but it is a differentiation. Let me try to put it here. It is the differentiation d by dq of, yeah, derivative of this total cost equation is what I get it as d by dq of the total cost function. When I get the marginal cost equation. So the total cost function is again given as 2 plus 3q plus 4q square, and I have to find marginal cost equation, marginal cost at q is equal to 10, and draw the graph of the marginal cost. Now, what does this concept of marginal cost means? It is a cost of manufacturing one more unit of the same product. Already, if 100 units are being manufactured, if I want to manufacture 101 units, what is the extra cost of manufacturing this 101 units is given by this concept of marginal cost. Now, in this problem, if I want to find the equation of marginal cost, I differentiate the total cost with reference to Q, and write it as derivative of the constant. Derivative of constant is 0. Derivative of 3q is 3, and derivative of 4q square is 8q. So finally, I write the answer as 3 plus 8q is the equation for the marginal cost. If I want to find the marginal cost at q is equal to 10, I directly substitute 10 wherever q is there, and I get the answer 83. And the nature of the graph of marginal cost again will be slightly U-shaped, but only difference is that marginal cost, when it falls much faster than average cost, and marginal cost, when it rises much faster than the average cost. So this is how the various cost concepts can be actually derived from the total cost functions. Now, in summary, what is the use of all these things is given in the summary slide. What does it say? The total cost and output data is available in all the industries. Every industry possesses the data of total cost and output. It is the job of the manager. It is a job of a manager or an analyst to collect these data from the finance department. So it is the manager who collects this data from the finance department and use it for cost analysis, or use it for analysis of the cost and for decision making purposes. That means in order to analyze the variation in cost and to help him in various decision making process, he will be calculating all the 7 concepts which we have discussed in the previous slides. The different cost concepts discussed here are useful to determine the level of output that can be produced at the minimum or the least cost. So what is the entire purpose of calculating all these cost concepts? It is basically helping the manager to decide what will be the output level which can be manufactured at the lowest cost. So the process of determining the output which can be manufactured at the lowest cost is a part of the next we can say the series of lectures, series of we can say videos we shall be taking. In this video, the basic purpose was to discuss the definition of cost function and try to derive the formulas or understand the formulas and the graph of the various cost concepts. I'm sure these slides and the discussion has been useful for you to understand the cost concepts in a very simple terms. Thank you very much for watching.